Welcome to my Texas workshop. I'm Randy Lammers.
I'm Aaron Keevan.
This is worth knowing. We want to wrap up our series on fastener finishes. So Aaron, we have three very important finishes that we want to talk about so that you can answer the question, what finish should I use for my application?
That's right. We're going to go over black oxide today, phosphates, and also E-coat.
Exactly. So all of these are black to some degree and very popularly used on fasteners. So let's start with black oxide. I want to also state black oxide and phosphate get confused all the time, so I want to kind of help adjust what that confusion might be and make sure we get it right. So black oxide. Black oxide is where your color black is the target. Yep. I want a nice, aesthetic black appearance with some minimal to average corrosion resistance. So the way this is done is they dip the parts in a alkaline solution at about 285 degrees Fahrenheit. Now, what that does is that transforms the surface of the steel. It transforms that steel surface. It does not add any dimension.
Yeah, no dimensions are added. So it's right. What they would call a conversion coating.
It's exactly, that's the correct word, conversion coating. So it converts the surface to a magnetite black surface, and it's a porous surface. So the porosity is there. That's important to us because that's what holds then the secondary process, which is then dipping it in a oil compound. Sometimes they'll dip it in a
waxes
or maybe even a lacquer to give it that nice shiny appearance. And it's the secondary process is where you get your corrosion resistance. So
exactly right.
Grab that. I actually went to the store. We were hanging a corner shelf, and my wife said, those nails, I can see the nails. And so we were able to find black oxide nails on the shelf that worked perfect. And you can see these are very well done, very nice black color. Now also, Aaron, grab those hex head cap screws. I brought these for a purpose. I wanted you to see that this can happen. If you'll look at the body of those hex head cap screws, it looks a little brownish.
Yep, definitely a little brown in appearance.
So sometimes if we don't get that transformation complete, you'll get some of that brown in appearance. So we have to make sure that the transformation in the alkaline solution is complete.
Exactly.
Because otherwise you're going to get some of that brown appearance.
What else can we apply this to? Have we seen this in stainlesses, I think, before? Is that something we can apply this for?
Yes, so thank you for mentioning that. We see a lot of stainless steel being used in the electronic industry. But they want it black. Yeah, black's the color of choice on electronics. So yes, you can do the same process and get that transformation on stainless steel. However, what you need to be aware of is that impedes the formation of chrome oxides. The way stainless steel resists corrosion is it forms a chrome oxide that continually washes away and it reforms.
Yeah, similar to what we saw in hot dip galvanizing and that patina. It's very similar with stainless.
It is. Very well put. That's a good way to put that together. I like that. So the black oxiding can impede that. And so be aware of that. It's not the same corrosion resistance. You looked this up and found a spec on this.
Yeah, so it's funny. I'm glad you mentioned this because in the ASTM standards, there's actually not a process that really covers black oxide. However, it is covered in ISO, which is 11408.
Okay.
And in that spec, they say you're supposed to meet 96 hours of neutral salt spray.
On stainless steel.
That's correct.
On stainless steel. So think about this. So stainless steel that we're used to seeing that will last a long, long time, with the black oxide, the ISO specification just brought it down to 96 hours. So that kind of confirms what we're talking about on the impediment of black oxide on stainless steel. But it's done all the time. We use stainless for a lot of different purposes. A lot of times dissimilar metals is one of the reasons why we use stainless steel. So therefore, it can be black oxide, and we see a lot of that. Great finish, great aesthetic value
And then
on black oxide.
Also, what thermal and chemical?
black.
What's the difference between those two?
Okay, thermal black. Thermal black is another controversy in the fastener industry, and where the controversy takes place is specific to socket head cap screws. This is where we see it all the time, because socket head cap screws in the inch series are a class 3 thread fit, and you don't have any additional room to add a finish on top of that. And so it's sold plain steel. Well, in plain steel, these socket head cap screws look black.
Yeah.
And the reason why they look black is in the heat treat process, the heat treatment changes, again, that surface to a black surface. But it's not the same as the chemical process we're talking about. It did not open the pores up. So whenever they then apply oil just to keep the parts, give it a shelf life, that oil sits on top.
Exactly.
So it's not the same corrosion resistance that we see with a true chemical black oxide.
Yeah, you see that embedment with the chemical process to help those oils, actually be in the porous layer. Right. And then something else that can happen with the thermal black oxide is you get a buildup of hematite.
Correct. So the hematite, it's a red substance that is in that transformation. You'll get to a hematite that'll be on the surface, and it's red, and it comes across as looking like it's rusted.
Like it's rust, yeah.
And so we'll get customers that will say, hey, I have these plain heat-treated fasteners, but I have rust on them already. Well, we always ask the question, okay, can you rub that rust off? When they say no, then we know it's hematite. If they say, yes, I can rub it off, then yes, that is rust.
Right.
So black oxide is a good finish. It's a good decorative finish. It has great aesthetic values for the right application.
Yeah. So that covers our black oxide. Now what about phosphates?
Okay, phosphates. Now phosphate is different. Sometimes it can look a little bit like black oxide, but it does have a different appearance to it. There are different types of phosphate. Now we're taking the parts and we're dipping them in a phosphoric acid and phosphate salts. That creates a phosphate crystalline structure on top of the surface. Now we're adding dimension. Okay.
Exactly.
And
yeah. This will have dimensional effects in comparison to the black oxide for sure.
And it's somewhere close to about 1.5 to 2/10 of a thousandth that you're adding up with this crystalline structure. Now, the crystalline structure holds the oil compounds.
Right. So we're seeing the same similarity that we saw in the black oxide.
This is where the similarities are with the black oxide and where the confusion starts taking place. But this time we've actually added dimension. We've added the oil compounds or sometimes a wax. And what's interesting about this is that you can spin the excess oils off so it's dry to touch. So in assembly, I can handle the parts and not get that all over my hands. But when you assemble the threaded fasteners, you actually shear off that crystalline structure and the oil comes out. You can actually see that in process. So it's kind of interesting to watch. So phosphate's real popular on fasteners.
Yeah, and then these are covered in ASTM F1137 and also ISO 9717.
Right, and there are different phosphates. So there's zinc phosphate. Now I want to tell you this. So the zinc phosphate is a zinc color. It's got that gray color to it, but be aware, when you put it over a heat-treated part, the black from the heat treatment does show through, so the part looks somewhat black. Some looks more black than the other. Matter of fact, pull those drywall screws over and let's show that to everyone. Now these drywall screws, I actually had to go through the shelf and I wanted to pick some that looked a little bit more gray. From box to box to box, the color changed from more blackish looking to more grayish looking. That's a zinc phosphate.
Yes.
If you had no heat treatment, it would be just that gray color. If black is your target, choose manganese phosphate because that phosphate crystalline structure in itself is black.
Yeah, it gives that nice uniform appearance.
And then we also have iron phosphate, very, very low cost, used as an underlayment for other coatings. So phosphate, that crystalline structure, is excellent to put down before you paint.
Yep.
And I think we talked about this in the dip spin coating, the zinc flake coatings.
Yeah.
They'll lay down a phosphate before they dip and spin on the zinc flake coatings.
And that's a commonality between all these different phosphates, the zinc, manganese, and the iron. They're all going to be a good underlayment for a coating or a painting.
Absolutely. Phosphates used very commonly on the drywall screws, on thread rolling screws, wood screws, the entire tapping screw category. Phosphate's a very, very popular finish for that, so it's excellent.
Yeah, and another one I can think of that's a highly decorative finish and really been used successfully in automotive is E-coat.
E-coat, so electrocoat. We have a lot of customers that have their own E-coat lines where they're painting whatever they're manufacturing, piece of what they're manufacturing. But we now have, and this is relatively new, we now have bulk processing for fasteners to put paint on fasteners. So we have a lot of customers, you mentioned the automotive industry is using it for internal screws. So you'll see a lot of black here again, internal screws. So grab those socket button head cap screws. We're selling a lot of these. E-coat are used on panels for panel screws where you have black panel and you want a nice, pretty, shiny, decorative paint, black paint look on panels. So a lot of that's taking place. Now, the process, Aaron, it's an electrolytical process that looks very much like a electroplating line.
Yeah, just like an electrodeposition.
Yeah, exactly. So you put the screws into a basket, and we're using the cathodic method because with the cathodic method, we're not worried about hydrogen embrittlement.
Exactly.
So,
anodic you would be, so we
stay away from the
primarily
anodic on
saying the
fasteners, and we use the cathodic method. So in the cathodic method, your screws get a negative charge. Now it's put into a vat of paint. The paint gets a positive charge, and the negative and the positives attract. Now what's really unique about this, the thickness of the coating is all about the viscosity of the paint, because once that paint is attracted over here to the metal fastener and that very micro spot gets paint on it, it cuts off that charge and no more paint is attracted.
Yeah, it's a really efficient process. Actually, up to 99% efficiencies are being seen in E-coat.
Absolutely, because it's just the paint.
Yep.
There's no really waste involved there. So when you think about this, then every piece of the exposed metal gets the exact same dimension of paint. Recesses, everything equally. So it's an excellent, excellent finish. And we're getting corrosion resistance up in the 200-hour range.
Yep. At about 20 to 25 microns thickness.
Yeah. Now, after it goes through the paint process and it's electrodeposited, then it does go into a cure oven.
Yeah, it creates cross-link on the actual paint itself
to be cured. There are some concerns with dimensions of parts that are kind of square in dimension, where you can get touch points, but we just kind of watch out for that. But other than that, excellent, excellent coating for threaded fasteners. Great aesthetic process.
So Randy, how many different colors can we get in E-coat?
Well, okay, paint comes in a lot of different colors. So to paraphrase Henry Ford, who when he made the Model T, he said, people, you can have any color you want as long as it's black. Aaron, that's kind of where we are on E-coat for fasteners right now today. The plating companies that are doing E-coat are only doing black. I guess if you had millions of dollars, you could buy another vat of a different color, but let's think black right now on E-coat. So, to wrap this all up, we've done a lot on fastener finishes.
Yeah, we sure have.
We started off with electroplating, where we took zinc anodes, we put them in electrolytic solution, and we applied zinc to the fastener.
And then we had the episode with the infamous salad spinner. That was zinc flake. So that was a dip and spin process where we applied that zinc flake directly to a fastener. That was cool.
Sure, dip and spin.
Dip and spin. And then the other one was what, hot dip galvanizing.
Hot dip galvanized, which is a excellent finish for external structural buildings, bridges, bolting to go with that in molten zinc.
Mechanical galvanizing and plating. That was the other one we covered. That where we can actually use this on high hardness parts such as socketed cap screws or even hardened washers.
Correct.
And it can be from very small diameter to very large diameter parts. So
Exactly. We use glass beads to peen that powder onto the material, onto the fasteners. So very, very good finish that we're really also excited about. So then, of course, today we have black oxide, we have phosphate, and we have E-coat. That's a lot. That's a lot of fastener finishes, and what we've covered here is the basics. There are other viable finishes out there on the marketplace, but what we hope we've done is help you answer the question, what fastener finish is right for my application? Make sure you watch all episodes on fastener finishes and choose the right finish for your application. They're all worth knowing.
you may have additional questions about fastener finishes. Leave us a comment and we'll be happy to get back with you.